This is 2014 FRQ number 5 in the non-calculated function portion. The twice differentiable function f and g are defined for all real numbers x. Values of f, f prime, g, and g prime for various values of x are given in the table above. A. Find the x-coordinate of each relative minimum of f on the interval between -2 to 3. Justify your answer. Well, in order for it to be a minimum, right? In order for it to be minimum, I need to go decreasing and then increasing, which means I need to go negative to positive for my f prime, right? So if you look over here, negative to negative, nope. Negative to positive, yes. So here, right here. So at x equals 1, that is when f prime change from negative to positive. Yep, that's your justification. Explain why there must be a value c for which for between -1 and 1 such that f double prime of c equals to 0. Well, let's check. When it wants you to compare an interval to a derivative, this is usually the mean value theorem, where it's asking you to compare some instantaneous velocity or instantaneous something to the average, right? So what do? We look for the f prime. So what it wants you to compare is f prime of 1 and f prime of -1, all right? What do I have? Well, f prime of 1 is 0. F prime -1 is also 0. So the slope of this, which is 0 minus 0 over 1 minus -1, is 0, right? So by mean value theorem, because this is twice differentiable, meaning it is continuous and is differentiable, that there is an instantaneous that equals to the average. I have proven to you that the average equals 0, therefore the instantaneous must also equal to 0. So by MBT, there is a c that equals to 0. Okay. Part C, the function h is defined by h of x equals natural log of f of x. Find h prime of c. Show the computation leads to your answers. So you need to find h prime first. H prime of x. Chain rule says natural log is 1 over f of x. And then the derivative of f of x is f prime of x. Okay. Really, this is f prime over f of x. All right. So I want h prime of 3. That's f prime of 3 over f of 3. All right, look at my chart. F prime of 3 is 1/2. F of 3 is 7. So I get 1 over 14. All right. Next, part D. Evaluate this integral. So don't let this scare you. You just need to take it apart piece by piece. F prime of g of x, g prime of x dx. So it's really u sub, right? If you let what's in the parentheses, there's so many parentheses, but if you let what's in the parentheses, which is g of x, be your u, then everything will work out really nicely. Because if u is g of x, and du is g prime of x dx, right? No coefficient. Okay, what about the intervals? Well, u of 3 is g of 3, which if you use your chart, g of 3 is 1. And then u of -2, I'm trying to change the old interval to be g of -2. So g of -2 is -1. Okay, all right. So if I plug everything in, my new integral looks like this. From -1 to 1, f prime of u, du, right? So what is the integral of f prime? Just f. So this is f of u, evaluated -1 to 1, and these are already in u, so I don't have to change it back. So it's f of 1 minus f of -1. Well, let's go back to our chart. F of 1 is 2, f of -1 is 8. So 2 minus 8, my final answer is -6. That's it.